again to switches, we need to find voltage, but the condition is that over here we have a capacitor. So when you need to find a voltage across capacitor, just keep one point in mind. You need to apply KCL. Again, the same point, it's repeated. If I need to find voltage across capacitor, keep that in mind. You need to find KCL. You need to apply KCL. But I'm talking about in terms of inductor. If I need to find a voltage, I need to apply KVL. In capacitor, if I need to find voltage, I need to apply KCL. So keep that point in your mind. So let's solve it, my dear friends. Same positions. First case, at t equal to 0 minus condition. When I say, my dear friends, at t equal to 0 minus conditions, that means my switch will remain at point 1. So let's observe the circuit. That means at point 1 it will be connected for a very long time. That means it will achieve the steady state definitely. So since the current is flowing for a very long time, the capacitor will be fully charged. Since it will be fully charged, the capacitor won't allow more current to pass through it. That means it will behave as open circuit. Simple logic. How much the capacitor will be charged? It depends upon the amount of voltage supplied to it. So the voltage supplied to it is 100 volts. So the capacitor charge will be equal to 100 volts. So in second case, what happens at second condition? At t equal to 0 plus, the switch moves from point 1 to point 2. When it moves from point 1 to point 2, so you have a voltage source, a resistance, and for capacitor you will be drawing a voltage source, which you obtain from equation number 1. So I need to obtain V of C of t. So again in this case, my voltage across capacitor is nothing but equal to 100 volts. So now let's observe my third condition. My third condition is t greater than 0. In this case, I'll be considering my capacitor. So let's draw the circuit. So my circuit in this case will be, I'll be having a voltage source 50 volts, a resistance 5000 ohms in this circuit, and a capacitor. So I need to find Vc of t, so I won't be putting the capacitor voltage over here. So if I need to find Vc of t, this point will be my Vc of t. So as I said, if I need to find capacitor voltage, I need to apply KCL, my dear friend. So I have two branches over here. One will be this, one will be this. If this voltage is minus 50, even the point value over here will be minus 50. So I have two branches, so my sub equation will be 2. So it will be applying KCL at point Vc of t. So we get, my dear friends, this will be Vc minus what you can see over here is minus 50 upon 5000. Why? Because you have you have two branches, your sub equation will be 2. So everything should be in terms of current because you are applying KCL. So V is equal to IR, I is equal to V upon R. Again, we need to apply the formula for capacitor for a current. So the capacitor for voltage formula is 1 upon C integration of I of t dt. But when I talk about capacitor current formula is given by it will be C dV by dt. So the value for capacitor is given as 1 into 10 raised to minus 6. So it will be dV upon dt, and sum of all current is equal to 0. Simplify the above equation. If we get Vc plus 50 upon 5000, 10 raised to minus 6, it will be equal to 0. Split it. The equation which we get is given as Vc upon 5000 plus 50 upon 5000 plus 10 raised to minus 6 dvc upon dt equal to 0. Whatever number you get, shift on RHS side. So you get d raised to minus 6 upon dt plus vc upon 5000 equal to minus 50 upon 5000. So get all the numbers in numerator. So here it will be 5000 inverse will be dv upon dt will be 2 into 10 raised to minus 4 vc. Next, minus 50 divided by 5000 will be minus 0.1. Since compare the above equation with the standard form, so dv upon dt plus vi, or you can write equal to pv equal to q, right? So compare this equation with this equation. I need to find the value for p and q. So my basic rule says my coefficient of dv upon dt should be equal to 1. That means I need to divide the whole equation by t raised to minus 6. So if I divide the whole equation by t raised to minus 6, so the equation which I get is bracket 2 into 10 raised to minus 4 divided by the value which I have bracket 10 raised to minus 6. So the value which I get is 200 Vc equal to, so next value is minus 0.01 divided by the value which we get is 10 raised to minus 6 joules. So the value which I get is minus 10 raised to 4. So compare the above equation. dv upon dt plus pv is equal to q. The value of p is equal to 200. The value of q is equal to minus 10 raised to 4. So your v of t value is nothing but equal to e raised to minus pt integration q e raised to pt into dt plus k e raised to minus pt. So simplify this equation. V of t is equal to e raised to minus 200 into t, q is minus 10 raised to 4 into p is 200 into t into dt plus k into the value of p which we get is minus 200 into t. So this term is your constant. Move out, take it outside. So the equation of v of t, my dear friends, in this case you get e raised to minus 200 into t. So the constant is minus 10 raised to 4. So it will be as it is upon 200 plus k e raised to minus 200 into t. So the base is same and the power, add the powers, you get v of t is equal to minus 10 raised to 4 upon 200 plus k e raised to minus 200 into t. So your v of t will be equal to 10 raised to 4 divided by 200, and the value which you get is minus 50 plus k e raised to minus 200t. So if I need to find k, my dear friends, for finding k I need to put the value t equal to 0. So the term which I get is v of 0 as minus 50 plus k, anything raised to 0 is equal to 1. So v of 0, that means at equal to 0, what voltage I got is 30 equal to minus 50 plus k shifted. So you get the value of k is minus 50. Put the value of k in this equation so that the voltage across the capacitor equation is given as minus 50 plus 150 e raised to minus 200t. That's the value across the capacitor which we got. So just keep that in mind, my dear friends. When I talk about capacitor, and when I talk about capacitor, I need to find the voltage across capacitor. In transient analysis, I need to apply KCL. When I talk about applying voltage or current across inductor, I need to apply KVL. So this point need to be remembered. Thank you so much, guys. Signing off.